Hi everyone, welcome to week 2 of maths. We're going to be moving on to something different now. We're going to be looking at measuring perimeter. I've got on a slightly different format this time in the hope that I can actually use the pen to draw to help what I'm explaining. So, let's get started. Okay, James says the side is 7 centimetres long. Do you agree? If you don't agree, what mistake do you think he's made? Okay, so I can see that he started measuring from 1 rather than measuring from 0. He's not placed his ruler at the correct starting point. Okay. Now, to be able to measure the perimeter, we are looking at measuring all of the outside edges. So I'm just going to change the pen colour so you can see this. So we're going to be looking at measuring the total distance around the outside. So we're going to be looking at there, 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 and there. Now I can see that this side here goes from 0 to 6, so I can see that this side is 6 centimetres. I can see that this goes up to 4, so this is 4, which means this is 6, and this is 4. So if I add them together, I've got 2 6s, which I know is 12, pop that there, and then I've got 2 4s, which I know are 8. If I add them together, 12 add 8, I have a total perimeter of 20 centimetres. Apologies for the handwriting, I'm trying to do this using a mouse, as you can see here. So, moving on then, have a go at this one on your own. I'll give you a couple of seconds to think about it. What would be the perimeter of this shape? Okay, so I can see that this side goes from here to here, and this is 10. I can see that this side is 2. I've got 2 10s, 2 2s, so I've got 20. I've got 4. If I add them together, I have a total perimeter of 24 centimetres. There we go. Okay, moving on. Now we're looking at perimeter of compound shapes. This is where we have 2 rectilinear shapes stuck together. So if you look here, we could imagine that this is rectangle A and this is rectangle B. And we're trying to work out the total perimeter of the whole shape. So to do this, it's no more difficult. We just add together all of the different sides, as shown here. When we add them together, we would end up with a total perimeter of 28 centimetres. Activity 1, both groups. I want you to imagine that each dot is spaced exactly 1 centimetre apart. So the length of this line would be 1 centimetre because there is 1 dot between. With that information, can you work out the total perimeter of this shape? And then if we doubled the length of each side, so if we made the whole shape twice as big, what would the new shape's total perimeter be? Have a go at that one, please, in your books. Pause now. Okay, so if I look here, I can see that the first shape was 10 centimetres. I have 1. I can see there's 3 here, 1 here, 1 here, there's 1 here, 3 here, 1, and 1. So I have 1, 2, 3, 6, and so on. And we carry on until we get to 10. Okay, if we look at this shape here, if we doubled it, we would end up with a total perimeter of 20. Activity 2. Now you're going to need to do this with a ruler. If you don't have a ruler, skip activity 2, move on to activity 3. I want you to have a look at drawing and measuring, and draw, measure and calculate a variety of rectilinear shapes, so shapes like this, with a total perimeter of 56. So you need to design a shape where if you added all of the sides together, you would end up with 56 centimetres. Ask someone at home to check that through if you've had a go at that. Okay, now sometimes we have a question where we're asked to find out which one doesn't belong and to explain our answer. Now, to do that, I'm going to need to work out the perimeter of each of these, and I can pretty much guarantee that one of them will be different. So if I start with the first one here, I've got a side of 9. Now I can see this as a square, so I know because it's a square that all 4 sides are equal. So if this is 9, then this is also 9, this is 9, and this is 9, which means this has a total perimeter of 30, oh, blimey, that's an awful 3, 36 centimetres. This one here, if this is 4, then this also must be 4. If this is 12, then this must be 12. If I add them together, I have 4 and 4, which is 8. I have 12 and 12, which is 24. If I add those together, I end up with a total perimeter of 32 centimetres. And then we move on to the third one. Once we've done that, we find out that the yellow square doesn't belong because it has a perimeter of 36 centimetres. The green rectangle and the pink shape here both have a perimeter of 32 centimetres, so the yellow one is the odd one out. Now, sometimes we'll be given a shape like this and asked to find out what the perimeter is, but it hasn't given us all of the information we need. We have a missing side here. Now, to find the missing side, we need to realise that we've got part of it here, which is the 4 centimetres, and the 4 centimetres goes from there to there. So we've got from there to there is 4. We've also got this part here, which is 8. So we know that the total of the bottom length is 4 and 8. So therefore, this side is 12 centimetres. We can now add all of the sides together to find out our total perimeter of 48 centimetres. Okay, have a go at this one, please. Same job, find the missing length. Use that to calculate the perimeter. So the missing length, we have 10, we have 8. We add them together, which means the missing side is 18. If we then add all of the sides together, we have a total perimeter of 60 centimetres. Using that, activity 3, both groups please, have a go at finding the perimeter of shape A, shape B, and shape C. Thank you. And here are your answers. Moving on, activity 4. We're looking at a little bit of algebra. So, we're asking to find out what is the perimeter of the rectangle if, firstly, the value of y is 1. So if we imagine that y, instead of being y is 1, that would mean this side is 2 times 1, and this side is 3 times 1. So therefore, this side is now 2, this side is now 3, which means this is 2, and this is 3. If I add those together, I have 4, add 6, with a total perimeter of 10 centimetres. Now, oh, that's not a very big ruler. Let me just turn this up. There we go. Okay, that was for part 1. Now for each time we look at it, it's asking us to change. So for the second one, the value of y is now 2. So instead of y being 1, it's now 2 times 2, 2y, and this is 3 times 2, so 3y. So now this side is 6, this side is 4, which means this is 6, and this is 4. If I add them together, 6 add 6 is 12, 4 add 4 is 8, add them together, we have 20. Use that information, have a go at the rest. There you go. And so on. So we would have 10, and you can work out the rest. Activity 5, this is mainly aimed at my group, but as always, you're more than welcome to have a go. One square sits within another square. The purple square has a 12 centimetre perimeter, so the total of this square's perimeter is 12. The green square's perimeter is 3 times greater. What is the length of each of the purple square's sides? what is the length of each of the green square's sides? Have you noticed a pattern? Explain your answer. What I would say with this one is remember a square has all equal sides. Okay, so for this one, each side is 3 centimetres in length, as 12 divided by 4 is 3. This is 3 times larger, so we take 12, times it by 3 to get 36, divide that by 4, meaning each side is 9 centimetres. Okay guys, thank you very much for the lesson. Let me know what you think, if you enjoyed the new way of setting out with the pen helping me to explain the lessons. If you do, then I'll carry on doing it this way. Until then, look out for the second video for today and see you all tomorrow. Thank you very much. Bye.